Today you're going to get an introduction to the periodic table, and you're going to color your periodic table according to the instructions. You should have a written set of instructions for this. You should have your getting to know your periodic table note sheet and the periodic table that we gave you that's plain, that hasn't been colored on yet. Those are the materials. You also need a red colored pencil, a blue colored pencil, and about 7 other colors. So here we go. The periodic table is really a lot more complicated than just a chart with elements listed. And as we go throughout the next couple units, it's literally, there are like mysteries embedded in the periodic table that will teach you how to read it and what kinds of things are there but are not written. There's a lot of information that's in the periodic table that's not written on the periodic table, and it's a really cool thing that you learn when you're in chemistry, that there's just a lot more there than what meets the eye. We are familiar with how symbols are written. They're always written with a capital and a lowercase. If there's 2 letters, if there's only 1 letter, it's a capital. Make sure when you write element symbols that you are doing that correctly. The first one is always a capital letter, and if there's a second one, it has to be written as a lowercase. When you look at the periodic table, it's important to know a few things. First of all, the metals are on the left. Okay, hydrogen, which is the top left box with the capital H in it, that is not a metal, but it sort of resides over there by the metals, so it's unique. Sometimes it acts a little bit like a metal, but it is absolutely not. So it's its own thing. But it is important to know that when we look at the periodic table, there are more metals than there are nonmetals, and the metals are found on the left and the nonmetals are on the right. Those boxes that you see shaded in purple, those are the metalloids. Those are elements that have properties that are kind of similar to metals, but also similar to nonmetals. So that's another category of elements. You can pause this video as we go through it and read some of the details. It is good to know a little bit about the differences between metals and nonmetals, and the fact that it's actually the way the electrons in atoms are arranged and behave that make the properties of metals and nonmetals different. At the bottom of your note sheet, if there's not a chart there that is a place for you to make a column with properties of metals and then a column with properties of nonmetals, then make a chart. Add a small chart to the bottom of your note-taking sheet and make a list of properties of metals and nonmetals so that you can reflect on those to study for tests and quizzes. Metals conduct electricity and heat well. We know that they tend to be shiny. The word ductile is a word you should know what that means. So if that's a brand new word for you, write it down. It means that it can be stretched into thin wires. Metals can easily be made into wires, and since they conduct electricity, that's why all of our electrical wires are made of metal. Malleability, or being malleable, means that you can shape and bend and pound metals into thin sheets, and then also therefore different kinds of shapes. Metals do corrode when they are around water. They do often react with air, oxygen in the air as well. Nonmetals are a little bit different. They're poor conductors. They don't conduct electricity. They don't conduct heat well. We use them to insulate things from heat and electricity. That's why wires are surrounded with a layer of a nonmetal, something plastic, so that the electricity is not going to be where we don't want it, like in our fingers, right? Nonmetals are brittle. They're not ductile or malleable. They tend to break easily. Sometimes they have a luster. There's a little bit of a shiny luster in the picture there, but they are not really shining like a metal. They're dull in comparison, and many nonmetals are gases. Metalloids have some properties of each. We call metalloids semiconductors sometimes because they conduct uniquely. Silicon is a very unique way of conducting electricity, and from that Computer chips were, of course, built around silicon's unique properties. When we look at the periodic table, one of the first things that's important to understand is that it is organized with all these numbers. If you look at your periodic table, at the top of each box there's a number. That is called the atomic number, and the periodic table has the elements in order according to the atomic number. You can see that on your periodic table. The vertical columns are called groups. They're also called families because the elements in a group have similar properties. So we refer them to families of elements. In group number 1, we have hydrogen, which is its own thing. It's not a metal, but those others, you'll find out soon that we call those the alkali metals, and those different elements have similar properties. And if we go to group 17, those elements that are in that group have similar properties. We call them families often. You can see that there are 18 groups total. When we look at the horizontal rows, we call those periods. And the elements in a period do not have similar properties. In fact, the whole idea of this arrangement is that if you line up all the elements in order of atomic number, periodically you find another element that's similar to some of the others. So the makers of our periodic table, by design, started to stack the elements that had similar properties. And we find that if we go from left to right in any period, we actually start out with an element in group 1, which is where the most reactive elements are. And then we go through some elements that aren't very reactive. And then we actually find some more elements that are quite reactive, in group 17 especially. And then in group 18 we find elements that don't react with anything. They're the least reactive elements. And so that those properties repeat periodically, and that is why we call the rows periods. And that's why we call the whole chart the periodic table. Anytime you see text, you should pause the video and read through that just like this was your textbook. Again, each element has a symbol. We're going to begin our coloring activity. Have your color pencils with you. Again, pause the video anytime you need it. The first thing you're going to do is you're going to mark over the line between the metals and the non-metals with a red pencil. This is the only place where I really want you all to have the same color. I want you to use the same color. Use red, because this division line between the metals and the non-metals is very important. And if it's bright red, you're going to find it. You're going to find on your periodic table that line is a stair-step shape, and it's already in your periodic table. You're going to find it between boron number 5 and aluminum number 13. It's actually not shaped exactly the same as the one in this picture on the PowerPoint. You can just follow the stair step that you have on your periodic table. Make that stair step line bright red. Color right over top of it in red. That is the division between the metals and the non-metals. We talk about these groups or families, and the first thing I want you to do as we learn some of the groups' names is to find hydrogen, which is number 1, and I want you to just color that light blue Just shade it in blue. When you're shading this, you can use a crayon or a colored pencil, but it's really important that you shade these, not color in with such a depth of like pressing the crayon down so that it blocks what you can read in each box. You want your final product to still be readable. You want to be able to read the symbol and the numbers in each of your element boxes. So just shade. We're going to give hydrogen a blue color, and it'll be separate from the ones around it because it is its own unique thing. It's not a metal, even though it resides over there. And you'll learn later why it's there. The rest of column 1 is a family we call the alkali metals. So we refer to group 1 as hydrogen and the alkali metals. Choose a color to shade the alkali metals, and then at the top of your periodic table you're going to make a key. An easy way to make a key is just to take that same color and make a list at the top. So if you chose a yellow or green or some color for these alkali metals, then at the top write neatly the word alkali metals in that same color, so you're going to be able to match the color later. And do the same thing with hydrogen. With your blue, you're going to write hydrogen at the top. The alkali metals are extremely reactive. It's the most reactive group. They're very soft. When we think about a metal, we think about iron or nickel, something that's firm, but the alkali metals are very soft and you can cut them easily with a knife. They are extremely reactive. You would not want to handle them. They would be dangerous. And they do not exist in the earth in an elemental form. You cannot find a deposit of an alkali metal natural in the earth. They are always combined with something else in a compound. So if you remember your history and you heard about the gold rush and how people would go out west and find gold deposits in the mountainside and in rivers, well, gold was a metal that you could find in its elemental pure state because it's less reactive. But these alkali metals you could not find that way. They're only found already combined with other elements. So if we want to take sodium or potassium and have some of those atoms collected together so that our sample was a pure element, we would have to take a compound from the earth, from our natural resources, that has this element in it, and then make a chemical reaction happen to collect the alkali metal in a sample that would be a pure element. In our group 2, you're going to select another color to shade and label this in your key at the top as the alkaline earth metals. These are the alkaline earth metals. You are going to be responsible for learning the names of these families, of these groups. And so make sure that you make a key at the top of your periodic table that you can read. The alkaline earth metals are also very reactive and also cannot be found in a pure elemental state in nature. They're always combined with other things. This middle section of the periodic table, we call this the transition metals. That's where you're going to find metals that you're familiar with, like iron and nickel, silver and gold, zinc. Those are where the less reactive metals that we use for coins, like copper and I mentioned gold. Pick a color to shade the transition metals, and then label that in your key. Transition metals are those that we do make things out of, like iron, and we make buildings and bridges. We use iron. We use it for our electrical wire, things like copper. Silver can be used as an electrical wire. Compounds of transition metals often have very specific colors, and some paints are named after specific elements. If you're an artist, you're familiar with cadmium yellow and cobalt blue. That's because the compounds of some of these transition metals have very specific, bright, and lovely colors. We're going to skip all the way over to group 17. You're going to choose a color to shade that, and those are called the halogens. So you're going to pick that color and then write in your key at the top the word halogens. Group 17 is the halogen family. They're very reactive elements. They include chlorine. Many people think chlorine is chlorine bleach, and there's compounds that contain chlorine in chlorine bleach, but pure chlorine is a gas and it's very dangerous. You wouldn't want to be around it. You wouldn't want to breathe it. So you're going to color your halogens and label that in your key at the top of your periodic table. Group 18 is called the noble gases. Those are the least reactive elements. They don't react with other elements. You won't find them in compounds. Sometimes they're referred to as the inert, I-N-E-R-T gases, inert, I-N-E-R-T, but they're called mostly the noble gases, and that's a throwback to history, back when some of these scientists were researching these different elements that they found, and they were studying them, and they found that these didn't react. And back then, when you thought about the noble class, the nobility, they didn't interact with other people, and so the noble gases got that name, similar to the noble class of people that were so prevalent at that time. Again, choose a color and make sure you include the word noble gases in your key. That section at the bottom, it's already labeled on your periodic table. It has the lanthanides and the actinides. Those are called the inner transition elements. The inner transition elements. And if you notice on your periodic table, you're going to see a place after element 56 and after element 88 where it says 57 through 70 and 89 through 102. Those inner transition elements actually are supposed to be right there in the middle of the periodic table, which would make the periodic table stretch much wider. And we would find that it would be a lot more cumbersome to have charts on paper that we could look at if we stretched our periodic table out like that. So that whole section has been removed and placed underneath the body of the rest of the periodic table. Select a color, and you don't have to shade them all the way in, but just draw around the perimeter of the lanthanides and around the perimeter of the actinides, and you don't really have to include those two names in your key because they're written right on your periodic table. So you don't need to include those in your key. Your key should have noble gases, halogens, alkali metals, alkali earth metals, and transition elements. The following groups are good to know, and we will talk about them, but you do not have to color them. I really only want you to color those sections of the periodic table that you are required to know those names of. So when we talk about the following groups, you do not need to color them. If we look at group 13, sometimes people will refer to that as boron's group. It has boron, and then there's our line for our metal and non-metal division. It includes, that group includes aluminum, which is one of the most abundant elements in the Earth's crust. It's a very important element. In group 14, we find that's where we find carbon. Carbon is a really important element because it's called the element of life. All living things are based on carbon compounds. Many carbon compounds are in plants and animals. So that is also called that element of life. Carbon has a unique way of bonding that we'll learn about later. And after carbon, we find nitrogen's group. Again, we do not need to be coloring these. Nitrogen is pretty important because it makes up the big bulk of air. We're breathing nitrogen in and out all the time. We think about air as having oxygen, but really there's a lot more nitrogen in it than there is oxygen. And then there is oxygen's group, which is group number 16. And you know how important oxygen is. We've talked about that. Oxygen is very prevalent in a lot of compounds that make up the Earth's crust. It's also the most, one of the more reactive things that we're going to find in air, okay? And we know that we have to have oxygen to have a fire. We've talked about that. Here's a nice chart to look at and study a little bit. It just talks about the different elements that are in the crust of the earth. That's what the world we know is the crust of the earth, the part of the earth that we live on and that we take our natural resources from is the earth's crust. And really, there's just a handful of elements that make up most of the earth's crust. Dmitry Mendeleev was a Russian scientist. He has a really unique story. He is the scientist who started organizing elements based on their properties and found out that if you organized them based on their atomic number, the size of it was kind of like the atomic mass at that time, but he started ordering these elements and found that periodically you would find another element that had the same properties. And so he actually developed this periodic table that we use now that was not as complete as it is now because a lot of the elements at that time had not even been discovered. And he actually, in his work, had made predictions and left blank spots in his periodic table saying there will be an element right here that will be discovered. And he made a list of properties and predicted what those elements would be like. In fact, he predicted them so well that at one point, when one of those elements was discovered, and I think that was in France, if I remember the story right, the scientist who discovered this element took measurements and studied this new element that they found and made a list of the properties. And Mendeleev, when he read about that research, said, no, that's not right. It's incorrect. And the story that I have heard is that once they reestablished the ability to measure those properties better, that Mendeleev was right. He hadn't even been able to experience in person this element, but his predictions were better than the people who actually discovered the element and their ability to take measurements about that element. So he was quite a remarkable man with a remarkable story. His personal story was quite interesting as well. But this concludes our coloring activity. Make sure you turn that in for points. Make sure that there's a key at the top. And we will move on from there.